So we'll move on to the next way of dealing with the expensive softmax. So remember that, so this is known as contrastive estimation. So remember that this is where we are in the story, that we saw the bag of words model, we saw the skipgram model, and we saw that both of them have this expensive softmax computation at the end, and that's the problem we are trying to deal with. So we saw one way of dealing with, which was negative sampling. So I hope you saw that there was no expensive computation there. The only computation there was the dot product between the two words which appear together or which do not appear together. Now let's see what happens in contrastive estimation. So here again you use the same idea. So you have a positive sentence or a positive example, he sat on a chair. You create a negative sentence which you replace the word by some random word. Okay. Now you construct a feed-forward network like this, which takes these two one-hot representations, basically uses your word context matrix to give you the summation of these two representations, right? That's exactly what we had done in the skipgram model. Now you have this hidden representation, which is the sum of the two word representations. Now from here on, instead of doing this softmax computation, which we had earlier, we just predict a single score, okay? We just predict the score for this word pair being a correct word pair. We do the same thing with the random pair. So we take SAT, we take abracadabra, and we add up their word representations. You get this hidden representation, and you get a score SR. Fine. So what's the output computation right now? Is it a matrix operation? Is it a scalar operation? Is it a vector operation? What is this? H is equal to, we need to change this to K on the slides, please note, right? So what is this product? W into H, just a dot product between two vectors, right? W is just K cross 1, that means it's a vector, okay? So as compared to K cross V earlier, we just have K cross 1. Do you get that? How many of you get this? So we have a very simple computation at the end. Okay, but now how do I set up my loss function? Earlier I could set up the loss function as maximizing the log likelihood of the correct word, but now just predicting two scores. So what is the loss function? What should I try to intuitively do? And today we are going to see a new loss function which we have not seen earlier. So try to think about this. What would you do? Forget about the math, forget about the machine learning and all that. What would you actually want? What is your wish list? That should be easy to characterize. Score S, score SR. Do you want this or this? First one, right? You want S to be greater than SR. Okay? Can you think of making an objective function out of this? You want to maximize S minus SR. Okay? Fine. That's a good starting point. So would you be happy with this? What would you want? This or this? Both cases S is greater than SR, right? What would you want? A big margin, okay? Fine. So we would like SR to be greater than S, and not just, so we could try to maximize S minus SR, okay? But we would also like this difference to be a certain margin. That means I would want S to be greater than SR by at least a margin of M. And that M is something I'll decide. So I could say that it should be at least 10 points greater than SR or 1 point greater than SR, depending on the scores that I have. If all my scores are between 0 to 1, then probably a margin of 0.3 or 0.4 is okay, sounds reasonable, right? That means S could be 0.6 and SR could be 0.2. Does that make sense? Right? So what I'm saying is, what I'm trying to say is that this is my SR. I want S to be greater than SR. I'm not just happy with that. I'm saying that even if I add a margin to SR, even then this condition should hold, right? And that is the same as saying that SR and there should be at least a margin of M between them. Okay, that's the difference that I accept. I'm not okay if you tell me that S is 0.99 and SR is 0.98, because then you're not really distinguishing much. I want at least S to be 0.9 and SR to be at least less than 0.5 or something. So there should at least be some gap between that, and that gap is M. Okay. So instead of maximizing S minus SR, I'm going to maximize S minus SR plus M. Is that fine? Okay. Now suppose you are at some point of training and you have reach some parameter configuration. That means you have learned some values for VC and VW, and you do this forward propagation, compute S and SR, and you actually find that this condition holds, right. So, right now my loss function is this. At some point you are doing this and you observe that this condition holds. That means S is actually greater than SR plus M. In that case, what do you want the loss to be? How many of you get the question? I want that S and SR should be separated by a margin of M in the favor of S. I am doing my training, I am at certain configuration for UCs and VWs and so on. I pass it to the feed forward network and I get S and SR, and I observe that this condition already holds. Okay. Is my network doing anything wrong at this point? It's doing its job properly. What should be the loss that I backpropagate? 0. Everyone gets that? There is nothing to correct here. I don't need to backpropagate any loss. So then can you give me the full objective function? Maximize this, but if this condition already holds, then don't do anything. Is that fine? So that's about this. So, and again observe that we have gotten rid of the expensive softmax computation.